All right, so we're gonna do a little practice double displacement reaction. Remember, our most helpful thing for that is gonna be our solubility chart. You're not expected to know everything's solubility. There are lots of solubility charts. You can get a lot more specific about how soluble something is, right? Just because we say something's soluble doesn't mean infinite amounts can dissolve. But this is kind of a qualitative, right? Not worrying about numbers, just in general, is it pretty soluble or is it pretty insoluble kind of thing, right? And we've also got our list of polyatomic ions. So there's 3 steps in doing these. Number 1, who do I compare, right? What do I want to look at? Number 2, then figuring out, does a reaction happen or not? If a reaction's not going to happen, you're just done. And then if a reaction happens, what are my products going to be? And I want to make sure and put those together as correct formulas, right? Not just slapping them together and guessing at things. So who do I compare? It's a double displacement, so they switch partners, right? So the partners they have here, they're going to break apart and they're going to come together here. I saw the other day a bunch of people were labeling things as positives and negatives, and I think that's pretty helpful because the positive from the first is going to get together with the negative from the second. So, and remember, we always write positive ones first. So aluminum is going to get together with hydroxide, and barium is going to get together with acetate. And remember, if you don't know the names of those, look off your polyatomic ion list. There's always going to be 2 parts. So even if it looks like there's a bunch of parts in something, right, that has a bunch of elements, well, that's one polyatomic ion where they're all covalently bonded together, but this is ionic reactions, right? So it's when the ions break up. So I need to look at aluminum hydroxide. So I go down to aluminum, right, and then over to hydroxide. Good idea to pause me and do that checking right now, right? So I would do that. Now, so when I look at that, I go down to aluminum, over to hydroxide, I see an insoluble. So I like to just go ahead, well, that one's going to be insoluble. And then I look at the other one, barium, down to barium and over to acetate, and that is soluble. You don't need both of them to be insoluble. You need either one of them to be insoluble or water or something that decomposes, right? So so we look at these guys. Well, the thing that drives this reaction to happen is our aluminum hydroxide, right? That's our driving force. So we did the who, that's these 2 and these 2. We did the is a reaction going to happen? Yep, I've got a precipitate that's going to form. So now I've got to put the products together correctly. So when I bring them across, we bring them across with their charges, not with their subscripts, right? So I will bring this thing all as one because that's acetate, but I'm not going to bring this 3 over. I'm going to bring this thing all together because that's hydroxide, but I'm not going to bring this 2. I'm going to put them together with their right charges. So when I put them over here, it's going to be aluminum and hydroxide. I need to think charges. Aluminum, all right, it's like chemistry just keeps building on itself. Aluminum being right here is going to get a +3 charge. Hydroxide on the back of our periodic chart gets a -1 charge. So if I've got a +3 and a -1, that formula needs to be AlOH3. And that was our insoluble thing. So instead of an S, I like to use a down arrow for that. Right, so that was my driving force, but I still need to have my other one, right? That would be kind of like your byproducts, right? We don't really care about this one as much because it's not actually coming together. They're staying dissolved in water, but that's the other thing in the solution. Same idea, I need to bring them across with their charges. So look ahead on that. What are the charges going to be? Barium gets a +2 charge. Hey, Mr. Arjwani. And hydroxide is, not hydroxide, acetate gets a -1 charge. Just a second and I'll be done. So that's C2H3O2, and that gets a -1. So I'll need parentheses and a 2. This one stays dissolved in water, so I'll do a little AQ to show that it's still dissolved in water. I like to come back and erase my charges so nobody confuses that those are ions and wasn't just some work that I was doing and stuff, right? So those are our 3 steps for predicting a reaction.